Welcome to the sleep session. I'm so happy that you guys are all in the blankets. It's so nice. Actually, Nina and I prepared the session together, and it's based on a book which is called Why We Sleep by a scientist, Matthew Walker. And considering what we heard from Anya just recently about the pyramid of different knowledges starting from opinion to international guidelines, this book is based mostly on meta-research, meta-analysis of thousands of different research which has been done in the past 20-25 years of sleep research. However, it has not reached the guidelines level yet, unfortunately, because a lot of things here also, the consequences of, let's say, sleep deprivation or different issues with sleep take a very long time in terms of years, an amount of years to appear, right? So it hasn't reached that point where the guidelines are official. Let's talk about the evolution of sleep first. The theory is that literally everything in nature sleeps in a way. And you will be surprised. The theory actually is that sleep was first and then it was wakefulness.
Wow.
So when at all life appears in the small cellular organism, they were actually asleep. We could count them as asleep. And then all of a sudden they were awake at some point. Because evolution-wise, sleep is so good that you don't actually need to be awake.
Okay.
So this is the theory, right? That it was first sleep and then it was wakefulness. Actually, going back, I can also mention that you ask what about plants? In terms of plants, they have a particular daily cycle that also is considered, part of it is considered sleeping, where they are more active in the, let's say, in the daytime and less active in the night, and maybe some plants vice versa, right? So they have the daily rhythm. We will talk about the daily rhythm later. But a proven fact is that NREM appeared before REM sleep. And do you guys know what's REM and NREM sleep? So
okay.
REM sleep stands for rapid eye movement. It's the part of the sleep where we see dreams. This is how you easily interpret it. When we see dreams, it's REM sleep. It's called REM, rapid eye movement, because our eyes are rapidly moving during that stage. That's one thing that you can notice even without having any scientific equipment. And that's why scientists kind of stuck to this REM sleep. Non-REM sleep is the other stage of the sleep. And we will talk about it. You have both. Us as humans, we have both in the night. The evolution-wise, NREM was first. So first, the bacteria and the cellular organisms and plants, they didn't see dreams. And at some point, we started seeing dreams in terms of evolution. Birds and mammals, we have REM sleep. And again, scientists did the experiments on mammals and birds, and they proved, based on the length of the waves in their brains, whether it's REM or non-REM sleep, because it's a particular wavelength. What is actually happening when we sleep? And how do you define sleep, right? What we are talking about. So first of all, there is a circadian rhythm. Circadian means daily, around the clock rhythm, right? It's our internal body clock, which is on its own, showing the body what time of the day it is. And we need it naturally for things like regulating activity when we feel the most energetic, when we feel the most tired and want to go to sleep. We have this circadian rhythm for hormones. Different hormones have a particular timing around the day when they are getting released and active. This internal clock helps us regulate our food habits or timings when we feel hungry. Usually, if we leave everything else, it will be at a particular time during the days and every day at the same time when we feel hungry. It also regulates our body temperature. There is a small curve and pretty much all the different chemicals. And circadian rhythm doesn't really depend on the daylight. So it is built in. And if there was no daylight and no days going around, and we just, the scientists, for example, did an experiment when they put, they went underneath the ground and they spent a couple of months underneath the ground to just see how it goes. It varies for different people, but for human beings, it's around 26 to 24 to 26 hours, our circadian rhythm. So it usually longer when you're younger and shorter when you are older. But the clock, the watch on our hand, the clock on the wall helps us to maintain the actual rhythm, which is according to the sun. So these small variations, they kind of don't matter, and in the night everything is rewind to zero, and from morning you're again in your regular circadian rhythm. It doesn't move, right? So that's one thing. And as I mentioned, when you have the most energy and when you have the most tiredness, it is also regulated, and obviously the tiredness means the sleeping time. Another thing is the sleep pressure. The sleep pressure is regulated by a hormone which is called adenosine, and this hormone is getting released in our body starting from early morning when we wake up, and the amount of this hormone builds up through the day, and at some point by evening reaches the peak. That's when we have the sleep pressure, what it's called, and our body feels the need to sleep. In the night, this hormone drops rapidly, and in the morning it starts again from, let's say, from zero, right? It builds up. And both of the systems work together. Our circadian rhythm works together with the sleep pressure. And you can see here on the graph that they get us sleepy at the same time so that we actually fall asleep. Some of you know what melatonin is, right? Melatonin. What is it? The thing is that melatonin is a hormone that shows our body what's the time of the clock it is. So it's not making us sleepy like adenosine. Adenosine is literally making us sleepy. So the more it is in the body, the sleepier we are. Melatonin just released when it's time to sleep. Melatonin depends on the daylight, right? So you don't have it randomly. It's released when the sun is down, right? And the thing about it is that melatonin pills, for example, that people sometimes take when they have jet lag and so on, they actually don't make you sleepy. They just show your body that it's time to sleep, sun is down, but then if you are not feeling sleepy, if you don't have adenosine, it's very difficult for you to fall asleep. So these pills are also very questionable, and you don't really need to take them, and the amount of dosage as well is very different in different pills. It's more of a placebo effect that they are producing. So what's caffeine then, and what does it make you feel, right, in terms of caffeine? Caffeine actually blocks the effect of adenosine. Right? So when you take coffee, tea, chocolate, whatever has caffeine, it temporarily blocks the influence of the adenosine sleeping pressure. on your body. So you don't feel the sleeping pressure, the build up of the sleeping pressure. And when the caffeine is released from your body, you all of a sudden get hit with the sleeping pressure which was built up in the hours of caffeine to be in, which was inside. So this is how the relationship is, and why, for example, some people are not falling asleep, cannot fall asleep when they take coffee and so on, right? It doesn't work the same for different people. As we know, some people can drink many cups of coffee and still perfectly fine fall asleep. But overall, internally, this is how it works. It blocks adenosine. Right? And finally, what happens in the brain when we sleep? First of all, there is a loss of consciousness about your surroundings. Right? This is a very perfect description of what sleep is. When you sleep, you don't really hear, understand, feel what's happening around you. And how it's happening, because the sensory data is still there. So you can still feel that you lie on the bed with your skin. You can still feel the temperature, hear the noises with your ears, and so on, right? No. It hits the thalamus, which then doesn't pass it to the rest of the brain. So it doesn't pass it to our consciousness, and we kind of the sensory data stops in thalamus. And the funny bit is actually when we see dreams, the sensory data comes from within our brain, and then that same thing works backwards when it doesn't pass it doesn't pass the information to our motor system. So when we see our dreams, if you noticed, your muscles are very relaxed. We can't move our body normally. In the normal state, when you see your dreams, you can't move your body. You're absolutely fluid. It is evolution method to prevent anything bad happening to us, because in the dreams we can run, we can hit, we can do something. So in reality we are just like that. So that's how it works in the brain in terms of different data going from one place to another. And in terms of the waves that Mike will like a lot, the pattern, there is a particular pattern on REM sleep and non-REM sleep that scientists find in birds and animals and human, and that tells them exactly at what stage a person is right now. During your wakeness, you can see this more or less synchronized, very small wavelength. During NREM sleep, the deep sleep, the brain waves are having very big, what is it called? They're amplified, right? Oscillations, right. And in fact, they are extremely strong and extremely synchronized, going from the middle of our brain like radio signals to the back. And that's how they spread, and that's what has this effect of recovery. So it literally makes the entire brain recover in this very, very steady rhythm, right? Thank you. And during the REM sleep, it's somewhat similar to our wakefulness, but even more random. So the waves are completely unsynchronized, completely random, and you notice it in your sleep. Reality feels much more logical than your dreams. So that's why in your dreams, the waves are going around the head completely randomly and connecting completely random parts of your brain. And in fact, the REM sleep is required or is very good for you to for your memory, for your creative thinking, for your language skills, and emotional intelligence. So again, during evolution, that's how it was developing, that at some point species, it started to be important for them to have those things, right? To remember stuff, to communicate to each other, to have some social skills and so on. They started to, I don't know, create flocks and herds and tribes. I also wanted to talk about dreams a bit. For example, there are opinions that dreams mean something, that they are somehow showing our subconsciousness, or they're showing unrealized wishes and so on, right? So all of these theories to date have been proven wrong. And the current theory of dreams is that it's just random associations that our brain tries to build to create different connections which we don't logically think of when we are awake. So it makes us literally more creative when we are sleeping. And it takes a random event from yesterday, connects to a random event from before, to something that we saw somewhere, something that we heard, puts it together, makes a scramble out of it. We think that our dreams are logical, and we kind of have this idea of a plot in a dream, but actually it doesn't exist. It's just completely random visual effects, even sounds. We feel we are doing something, meeting somebody, and so on, but it's absolutely random. And one more important thing, actually, which I was reading about in terms of bad dreams and the influence of dreams on trauma and depression. The simple way to explain here is that let's say something happened to us which is not good, right? It had a very strong effect in our brain. It had a big impact. In the night, the brain thinks that because something had a big impact, it needs to repeat it somewhat. We need to remember this, right? So it starts to make the pattern. In the morning, if we think of it again, saying, and we process it in our mind, going over it again, it happened yesterday, then I dreamt about it, and then we amplify this effect, and we think the same thoughts, reinforcing the same mental connections and the same connections in between neurons. Our brain next night thinks again that it was obviously very important, because already for 2 days we have been reinforcing the same connections. So it again gives us the same information, and that's how it goes into chronic kind of into downward slope, you can say.
Yeah,
so the best is to clear your mind somehow, however you can, and forget about the bad dream, and try to forget about what happened, bad thing to you, and try to reinforce some positive things in your mind. And obviously we can talk about meditation here, how it helps as well in terms of breaking the negative connections, right, in the brain. So this slide depicts the cycles of the sleep during the night. It's a common knowledge, and maybe you heard of it, that the regular sleep cycle, or we sleep in 90 minutes periods.
Yeah.
So 1.5 hour periods. When we just fall asleep in the beginning of the night, we have mostly NREM sleep. So scientists find different stages, 1, 2, 3, and 4 stage of NREM sleep. It means that you fall deeper and deeper and deeper into NREM sleep, and then you stay here and NREM for a longer period in the first 90 minutes. Then it's shortening, and this is the REM sleep. Yeah. So the NREM is shortening, and REM sleep is more longer. And then in the end of the night, what you have is almost everything is the REM sleep, right? So that's why when we wake up, often we remember our dreams, because we just saw them.
Yeah.
Right? And when you wake up earlier than you're supposed to, then your body is supposed to wake up, you cut on your REM sleep. And NREM sleep is mostly good for revitalizing the entire bodily systems. We will be talking about microsleeps later a little bit, but now I want to pass it to Nina. Yeah.
Thank you, Nastia. So today, now at the moment we will speak a little bit about different, how much we should sleep in different stages in our life and what's the rules, or do we have rules or not. A lot of doctors can tell us that in different stages of the life we should sleep different time. So it depends of your ages, and most of the case when baby born, he or she should sleep near 19 or 20 hours per day. It's normal and it's okay from until 1 year or 1.5. After this, from 1 to 3 years old, it's good, and it's good for health and for everything to sleep near up to 15 hours per day. From 3 to 7 or to 8, it's good to sleep 11 hours, 11, 10. Until 16, it's good to sleep 10, 9. And after 16, when we adult, it's good to sleep 8, 7.5 and 8 hours. And it can help you to recover during your sleep. And on this page you can see, and when you're adult, you also should sleep like 8 hours, but your stages during the sleep, like REM and non-REM, there is difference with the same stages in your younger ages, and it's also impact in your recovery, your body, your immune system, your everything about it. So memory process, we can divide it into three parts. It's encoding, consolidation, and recall. So the sleep play a huge role in the second part, in consolidation. So when in the first part, encoding, we get information and like feed it like in our body, but in the consolidation, it is during this part the knowledge, the information, it's transformed from initial story to long-term story, and it's transformed to our muscles memory, and when we wake up, we use it as a skills, as our knowledge, and it's help to have this like our new opportunity to do something and to use this knowledge as in your ordinary life. And if you don't have enough sleep, you don't have this process, and you limit yourself to have this new ability, new opportunity to create something better, to do something new, and so on. Why it's happened? Because when your brain sleeps, it organizes all of information which you which you get during the day, and when you sleep, your brain helps you stop have stress, and it's reduced stress, and you also intake all of information and transferred from initial memory to your long-term memory, and you will use it in your practically day in in future life.
And here is the example, how when the kids are cranky, and parents say, oh, he needs to go to sleep, or he didn't get enough sleep. It's exactly the same for grown-ups. When you as a person, or I don't know, somebody at work is it cannot control his behavior, her behavior. It just means that the person has lack of sleep. This is one first thing that somebody can do to improve the communication skills, leadership abilities, productivity, and so on.
So, and if you want to do it in your company, you should like present this science experiments, this researcher, because if your, for example, boss doesn't know about it, it will be very difficult to explain why you want to sleep more, because I will be more productive, more I have better decision and so on. And it's good to present some researchers and explain why. It's not because I am lazy and I want to sleep all of my life, but because of this, and it's really work. I like have this experiment during last 2 months, and I really becomes to sleep longer, and I become more effective, and I feel better myself, my memory and so on.
So the longevity implications. The most interesting part of it that we were waiting for, I think. The first one is very simple as safety, right? Because if you just die in the car accident or do something wrong and die, your longevity is also stopping there. And sleep has a drastic influence on our safety. Here the research shows that there is a 400, or you can say 4 times drop in your concentration when you miss 1 night of sleep. So just in 1 night of sleep you are 4 times worse in reaction, in focusing. Let's say we're talking about driving right now, but anything. If some other people at work need to perform something where the lack of concentration can be little, also obviously it's not good. But 1 night of sleep is rare, right? Especially when you are an adult. It's the same when you have 6 nights of sleeping of 4 hours, and it's this.
Not quite rare.
See, Anya?
No,
And it's the same when you have 10 nights of sleeping of 6 hours. And this is sometimes surprising for people, because a lot of people sleep 6 hours, like a little bit more, 6 to 7 hours, and consider it's normal. But after just 10 nights of sleep of 6 hours, your lack of concentration is as bad as if you didn't sleep at all. And the worst part of it, that people don't realize how bad it is. This is back to Anya. So according to all the research, when they asked to be self-assessed, how is your lack of concentration, how do you feel and so on, their data is absolutely unrealistical and not matching the data that the real results are showing. So people don't understand how bad it is. Okay, second is dementia. We already spoke about the influence of REM sleep specifically on your cognitive abilities, memory and so on. And dementia is one of the things which lately is associated with, development of dementia is associated with disruptance of sleep. Very, very tightly, right? It's still not sure which causes which comes first. The lack of sleep causes dementia, or dementia causes the lack of sleep, but both are going hand in hand. Simply, there are no people with dementia who sleep like babies, and there are no babies with dementia. So just to give some statistics, 1 out of 10 people above 65 will develop dementia at any point of life, and the sleep disturbance is the early sign of potential dementia. So if you are, let's say, closing 65 or a little bit earlier or a little bit after that, and you have problems with sleep, it's an early sign that you might be developing dementia at some point. And the theory is that there is beta amyloid, which is a toxic protein. So we were talking about the protein junk. So beta amyloid is one of the examples. It is proven to have roots in dementia, which means that
it's one of the kind, because the dementia is not the illness, it's just a syndrome, a sign of several diseases. And those beta cells, these are about the Alzheimer disease.
Alzheimer. If I took it back, Alzheimer is the most common out of all of them. That's why we're talking about it, and Alzheimer and then Parkinson's, of course, but Alzheimer is the most common out of all of them. I think above 90 or 95, every third person have Alzheimer's disease. So if we're talking about beta amyloid, basically it's aggregating in the same place where the brain is producing, and now here I am looking NREM sleep. So it's the NREM sleep, which is the most important here. You remember I was talking to you about the waves, the deep waves, which go from your prefrontal lobe throughout the brain through NREM sleep, right? It's very perfect, synchronized deep waves. Dasha? So the prefrontal lobe is also responsible for our cognitive abilities. And it's this place where this amyloid is also getting accumulated. It's actually getting accumulated throughout our life as we go, but in the common sleep pattern, when we sleep properly throughout life, it's getting washed out through the night. So whatever minimal amount it accumulates, it's getting washed out, it's getting cleaned out, drained out. And it starts accumulating when we don't have enough sleep and it doesn't get drained out in one night, then in another night, then in the third night, and it's accumulating, basically clogging up the receptors, the neurons of the brain. And because it's going on here, it's decreasing our cognitive abilities. We're losing memory, we cannot understand things anymore, don't recognize people. And also it disrupts our NREM sleep because those proper waves are not possible anymore because it's all in the same. How is this amyloid getting removed during sleep, right? So we're talking about longevity, meaning good sleep increases your life, decreases your Alzheimer's disease risks. Well, it pushes it up in your life because they say that Alzheimer's is also genetic, and it helps you get it later at the later stage, or sometimes you have it but you don't have symptoms. How does the sleep help? There is lymphatic system in the body. There is similar version of the system in the brain, the lymphatic system, which washes away all the debris. And amyloid is the debris that it washes away during the night. So the proper sleep we get in the night, the system works for us. So the more disruption we do to our sleep now in our normal age, the earlier those signs and the earlier this amyloid will start accumulating, and the earlier those signs will start appear. So this is very important. And here it's the pattern is like this. The more amyloid, less NREM sleep, less NREM sleep, more amyloid, and so on, and it's a loop again, right? So this is dementia. Now, immune system. You heard of this common knowledge as well when you kind of feeling funny and coming down with something. People say, or you think yourself, okay, why don't I just drink some tea, get in bed and have a good night's sleep so that tomorrow I am good, right? So this is how sleep works for our immune system. So according to the research, you can see here the scale. The people were given a virus night before, and one group had a good night's sleep, the other one didn't have. I think they slept, I will tell you. One had less than 5 hours, the other half had more than 8 hours, and the difference between them getting sick was drastic. Those who slept less than 5 hours, next morning half of them fell sick. Those who slept more than 8 hours, only 18% were sick, right? So it's really good not just for not getting sick, but also when you're taking a shot, a vaccine, and you don't sleep well after this vaccine for at least couple of days, this vaccine will not be as good for you as if when you slept for at least good 3-4 nights after you took the vaccination. So the same effect on the immune system. Third one is cancer. Lack of sleep basically influences cancer development or cancer development in two different ways. One, cancer has at any point of time in our body there are cancerous cells which are getting produced in different places, and our immune system is able to kill them out when they first meet them. And since we spoke about the immune system getting better in sleep, when you don't get enough sleep, you lose 70% of the ability of this system to kill cancerous cells. So you're increasing your risk to actually start them and make them flourish. From the other side, we spoke about inflammation, right? Inflammation being quite an important or quite a bad thing for us, right? In terms of inflammation, it comes from the SNS. So it's a sympathetic nervous system, right? So sympathetic nervous system is basically everything, like it goes through our whole body, and this is the system which reacts onto stress and produces different hormones that doesn't allow us to that keeps us in a fight or flight mode, basically, right? And doesn't allow us to become calm again. And constant fight or flight mode is dangerous for cancer in a way because inflammation is first of all opportunity for cancerous cells continue destroying DNA, so they feed off the inflammation and continue growing. Secondly, it's an opportunity for cancerous cells spread around the body through the inflammation. When cancer literally can move from different parts, it started in one part and moved to another part. Again, coming back to night shifts, right? So we were talking about different statistics. So less than 6 hours of sleep increases 40% risk of cancer. Loss of sleep in mice, mice we were talking about, is twice increase of speed of cancer growth. So again, we were talking about them just looking at it, comparing it within days. It was twice faster in those who didn't sleep well. Then one sleepless night is twice decreasing or 2 times decreasing your gene activity. So again, talking about the genes, right? Sleep also influences how your genes work and which one is getting active and which one is getting passive, right, or not deactivated. We have some genes which are good for the body, like helping us with the immune system and so on. So the good ones becoming deactivated in lack of sleep. And the bad ones, those who are helping cancer cells to grow, those who are helping inflammation to develop, they are getting active in the sleep. And here is the Denmark Denmark example, where on the governmental level they accept that night shifts are causing cancer, and they are paying people much more for the night shifts. Cardiovascular system. Sleep is having even more influence on cardiovascular system than in case of cancer. So first of all, it increases the heartbeat and the blood pressure, lack of sleep. It also helps erosion of the fabric of the blood vessels, so lower veins and so on, arteries. The system, the fight and flight system that we were talking about, it increases the cortisol level, which further increases the blood pressure, and the growth hormone is not produced, which might be good in some cases for longevity, but in cases of cardiovascular diseases, because your vessel's fabric is damaged, the lack of growth hormone is preventing the healing of those vessels. So you kind of need the growth hormone for healing here as well. One large study that was given as an example is the shift from daylight to daylight saving time shift, where the experiment is global, and changing it by 1 hour increases the heart attacks by 40%. So in that one day, 40% more people than average get heart attacks. And it drops when it goes back. So diabetes, the normal process goes like this, you don't see, but when the sugar comes to blood, you all know, the insulin gives the cells a signal that they need to open up to absorb the sugar, right? So when you have sleep loss, the insulin is still producing, maybe slightly less, but the cells are completely stubborn and adamant, and they don't react on insulin at all, and the sugar is just going around. The fact of the matter is that 6 nights of 4 hours of sleep will make anyone with good health to be diagnosed with pre-diabetic state. So your analysis of the body would be pre-diabetic, and doctors will already give you some measures how to cure it, and it's just sleep.
So the most crucial questions, so how much time is enough to sleep? So by scientific science, the 8 hours and 35 minutes, it's a good time for sleep.
That's why I know it. I did the presentation, right?
Yeah, and so some way to have a healthy sleep. So let's understand what is time to go to bed and to wake up is better for you. To fix the slightly cool temperature at the room, and stop to drink coffee, tea, and some also eat chocolate before 4 hours before when you go to sleep. It will help you to get healthy sleep. Don't do exercise like exactly before you go to bed. And if you couldn't sleep, wake up, do something, and after goes again to try to do it again. So it's some very easy steps, but they're very important and crucial if you want to have some regime and to be healthy and live longer.
Sleep has the restorative function for nearly all the systems of the body, and you cannot sleep it off. So for me, I implemented this rule by choosing every time, if I have a choice, to sleep rather than do something else in the night specifically. Sometimes you feel like continuing work. It's me, like I'm energetic in the evening. Sometimes I feel, I can continue to work, I have this inspiration into the night. No, I choose to sleep now after knowing all of this. So sometimes I can plan something with my friends very late. If I can reschedule it, I would reschedule it. Watching a movie in the evening, for example, or going with my husband for a movie for the last screening, I would reschedule it. Like things like that. If I have a choice, I'm now prioritizing sleep. and it's impossible to sleep it off. Whatever harm we cause by sleepless nights, by lack of sleep night to night, it's not reversible.
Да.